Have you ever felt like you're in two places at once? Maybe you're physically at work, but your mind is already on the beach, sipping a cool drink. Well, what if I told you that in the bizarre world of quantum mechanics, tiny particles can actually be in multiple places or states at the same time? Sounds like science fiction, right? But it's a real phenomenon called superposition. Stick with me, and I promise by the end of this video, you'll have that aha moment, even if you've never taken a science class in your life. Let's start small. Imagine our world, the world we see and touch. If I toss a coin, it spins in the air, but when it lands, it's either heads or tails. It can't be both. Simple enough. This is what we call the classical world. Everything is definite. A car is either moving or it's not. Your cat is either on the couch or under the bed. But when we zoom in, way down to the level of atoms and the even tinier particles that make them up, like electrons, the rules change completely. These little guys live in the quantum realm, and it's a wild, weird place. So, back to our coin. In the quantum world, an electron is like a spinning coin that never lands. As long as we're not looking at it, it's not heads or tails. It's in a fuzzy, probabilistic state of being both heads and tails simultaneously. This is superposition. The electron exists in a cloud of all its possible states at once. Think of it like a light switch with a dimmer. In our classical world, the switch is either on or off. But a quantum switch is like having the dimmer set somewhere in the middle. It's a bit of on and a bit of off, all mixed together. The electron isn't in just one spot. It has a probability of being in many different spots around an atom's nucleus, all at the same time. It's a cloud of possibilities. So if it's always in this fuzzy state, how do we ever know where anything is? This is where things get even stranger. The moment we try to measure it, the moment we look at the electron to see if it's heads or tails, the superposition collapses. The spinning coin instantly lands, and we find it in one single, definite state. It's as if the particle knew we were watching and decided to pick a spot just for us. This act of observation fundamentally changes the outcome. It's called the observer effect. Imagine you have a magical, invisible cat in a box. As long as the box is closed, the cat could be doing anything. Sleeping, playing, chasing its tail. It's in a superposition of all possible cat activities. But the second you open the box to check, you find it doing just one thing. Say, sleeping. Your act of looking forced it into a single reality. This isn't just a quirky thought experiment. Superposition is the backbone of some of the most cutting-edge technology being developed today, particularly quantum computers. Your regular computer, the one you're watching this on, works with bits. A bit is like our classical coin toss. It can only be a 0 or a 1. On or off, heads or tails, that's it. But a quantum computer uses qubits, and a qubit, thanks to superposition, can be a 0, a 1, or both at the same time. This ability to exist in multiple states at once means a quantum computer can process a mind-boggling amount of information simultaneously. Imagine trying to find your way out of a giant maze. A classical computer would try one path, hit a dead end, go back, and try another. It would check every single path one by one until it finds the exit. It's slow and methodical. A quantum computer, on the other hand, could explore every single path in the maze at the same time. It's like having millions of versions of yourself running through the maze simultaneously. As you can imagine, it would find the exit almost instantly. This incredible processing power could revolutionize everything. It could help us design new life-saving medicines by simulating molecules in a way we never could before. It could create unhackable encryption to protect our data, develop powerful new artificial intelligence, and solve complex problems in finance and climate science that are currently impossible for even the most powerful supercomputers. Now let's touch on another equally mind-bending quantum idea: entanglement. Albert Einstein famously called it spooky action at a distance. Imagine you have two of our special quantum coins. You link them together in a special quantum way, so they are entangled. This means their fates are intertwined, no matter how far apart they are. If you entangle them so that if one is heads, the other must be tails, and vice versa. Now you put one coin in your pocket and give the other to a friend who travels to the other side of the universe. Remember, as long as no one looks, both coins are still in a superposition of being both heads and tails. But the moment you look at your coin and see that it's heads, you instantly know faster than the speed of light that your friend's coin on the other side of the universe has just become tails. It's not that it was tails all along. The act of measuring your coin instantaneously affected your friend's coin, forcing it out of its fuzzy superposition and into a definite state. It's like having a pair of magical gloves. You know you have a left and a right glove, but they're in identical sealed boxes. You send one box to your friend on Mars. The moment you open your box and see you have the left glove, you know instantly that your friend has the right one. There's a hidden connection between them. Quantum entanglement is that connection, but for particles. This is not just a theory. It's been proven in experiments time and time again. This very real, very spooky connection is the basis for technologies like quantum teleportation, not of people, sadly, but of information, and ultra-secure quantum communication networks. So, what does this all mean for us? Why should we care about these strange, tiny particles? Because understanding the quantum world isn't just about abstract physics. It's about understanding the fundamental nature of reality itself. It challenges our intuition and forces us to accept that the universe is far more mysterious and fascinating than it appears. The phone in your hand, the GPS in your car, medical MRI machines, all these technologies rely on our understanding of quantum mechanics. And the next wave of innovation, from quantum computing to new materials, will come from us continuing to explore this bizarre and beautiful realm. The world at the smallest scales doesn't follow our everyday rules. It's a world of probabilities, not certainties. A world where things can be in many places at once, and where particles can be linked across galaxies. It's a reminder that there's always more to discover, and that the biggest breakthroughs often come from asking questions about the things we take for granted. So the next time you feel like you're juggling a million things at once, just remember the humble electron. It's in a constant state of superposition, effortlessly being in multiple states at the same time. Maybe we can learn a thing or two from it. I hope this has helped demystify the wild world of quantum mechanics just a little bit. It's a huge topic, but hopefully, you've had that light bulb moment with superposition. If you enjoyed this journey into the bizarre, please hit that like button and subscribe for more deep dives into the amazing universe we live in. Thanks for watching, and stay curious,